Good morning, class. We are looking at exam 2 review, chapter 3 derivatives. We're going to cover from 3.2 to 3.5. The derivative as a function, basic differentiation formulas, the product and quotient rules, the chain. First, the secant line, given 2 points, we can calculate the slope, f of x minus f of a over x minus a, f of a plus h minus f of a over h, and otherwise. To get to the slope of a tangent line at point A, f prime of A is the limit of f of x minus f of A over x minus A as x approaches A, or limit of f of A plus h minus f of A over h as h approaches 0, giving rise to the equation of a tangent line y minus f of A equals f prime of A times x minus A. And again, you don't have to memorize it, just remember the point slope. Y minus y1 equals m times x minus x of 1. Definition of a differentiation: dy dx is limit of delta y over delta x as delta x approaches 0, or f prime of x is limit of f of x plus h minus f of x over h as h approaches 0. And we have different formulas. The derivative of x is 1. X is the independent variable when we say ddx of x. ddx of c f of x is c ddx of f of x, meaning if you have a constant in front of a function, you can take it out. The derivative of a sum is the sum of the derivatives. The derivative of the difference is the difference of the derivatives. These are some basic differentiation formulas we should know. The derivative of a constant is 0. Kx is k, x to the power of n. This is known as a power rule. ddx of x to the power of n is n, x to the power of n minus 1 has a lot of usage. The derivative of e to the power of x is itself. Sine is cosine, cosine is negative sine, tangent is secant squared, cotangent is minus cosecant squared, secant is secant x tan x, cosecant x is minus cosecant x, cotangent x. A to the power of x is itself a to the power of x times ln a. This is the shorthand notation for the product rule. Fg prime is f prime g plus g prime f, and f over g prime, that's the quotient rule, f prime g minus g prime f over g squared. Composite function, f of g equals f of g of x. Its derivative is f prime of g of x at times g prime of x. In Leibniz's notation, dy dx is dy du dx. And the extended power rule, if you look at the power rule, x to the power of n is n, x to the power of n minus 1. This is n g of x to the power of n minus 1 times g prime of x by the chain rule, reminding you of the natural log. Y equals ln x means log x base e. We don't write it in this format. We write it as ln x. By definition, e to the power of y becomes x. We want to differentiate this, and the very first thing is to notice x to the power of 5 over x to the power of 9. We can use the quotient rule and make it x to the power minus 4. And now the derivative f prime is 2 over 9 times minus 4 x to the power of minus 4 minus 1 or minus 5. So you get minus 8 over 9. X to the power minus 5 goes down. So we have minus 8 over 9 x to the power 5. For part B, if you have a rational function or a fractional format where you can get rid of the denominator somehow, in this case, you can factor the x squared out. The answer is f prime of x equals minus 7 in a split second. However, if you try to do the quotient rule, it takes much longer. You don't want to do that. Also, if this is not x squared, it's not a monomial, it's like square root of x. You change it to x to the power of 1/2, and again, you make up two fractions, and in the same manner, you can simplify it. Y equals 2 to the power of 7x. We want to differentiate, reminding everyone the derivative of e to the power of x is itself. The derivative of e to the power of kx is itself times k by the chain rule. E to the power of g of x, again itself, times G prime by the chain rule. But we haven't discussed base other than E. We have in lectures, but just to remind you, if it's B to the power of X, you use the fact that E to the power of ln X is X, and you change it to a format such that the base becomes E. So E to the power of ln B times X. Please understand ln B is a number. So what you're looking at in essence is K. So in essence, it's K times X. So it's itself times K. K happened to be ln B. Now, as you know, this is B to the power of X. Return it in the format you received. Meaning, exponential, the answer is itself. The base is E, you're done. If not, ln B. What about B to the power of f of X? Again, the answer is itself. Is the base E? No, ln B. Is this X? No, f prime of X by the chain rule. So the answer is itself, 2 to the power of 7X, because it's an exponential format. Is the base E? No, ln 2. 7X, the derivative is 7. Now we are done. We just rewrite it. 7 ln 2 in a parentheses times 2 to the power of 7X. Cosine in all cases. So you want to take the derivative of cosine 2x. I remind you what I mentioned before. Anytime you're dealing with a trigonometric function, just read cosine, not the argument, and stop. And the answer is negative sign, and stop. Every trigonometric function must have an argument, and it does. So you have to use the same argument. And now by the chain rule times 2, the answer is negative 2 sine 2x. Or you can use this formula. d dx of cosine u is negative sine u du dx. Or this formula. d dx of cosine of g of x is minus sine g of x, g prime of x. Number 2, rewrite it as cosine x to the power of 2. If you don't have to, you don't have to do that. If you recognize that as the power rule, and therefore you are using the extended power rule, so you are going to say y prime is 2 cosine to the power of 2 minus 1, or simply 1. By the extended power rule, we need the derivative of that, minus sine, and you write it as negative 2 cosine x sine x. This one, again, cosine, and pause, negative sign. But every trigonometric function must have an argument, so it's the same argument. By the chain rule times 2x, and you put it in front, you get y prime equals minus 2x sine x squared. I mentioned mixed derivative practice. These are some of the practice tests that you can find it under the modules of Canvas. It's been given, and the purpose of that was to get you ready for the exam. Sine squared 8 to the power of x. We're going to write sine of 8x to the power of 2. It makes it easier to see that you're dealing with the extended power rule. So 2 sine 8x to the power of 1, or simply sine 8x. And now you wanted to take the derivative of sine of 8x. By now we have enough experience. The sine becomes cosine, and then 8x gives us 8. Put them together, 16 sine 8x cosine 8x. H of x is 3x times 3 to the power of x. We need the product rule. It's the product of 3x and 3 to the power of x. So we're going to use the product rule. I would write the product rule, and I follow that. F prime g plus g prime f. F prime is 3. times g, 3 to the power of x, plus g prime. Now, I want to differentiate this. We've discussed that. Any exponential, immediately the answer is itself. You look at the base is e, you're done. It's not ln 3. You look at the exponent is x, you're done. If it's not by the chain rule, you take a derivative of that expression. X, the derivative is 1, you don't have to worry about that. And so that's g prime times f. So please understand, this is f prime g, this is g prime f. If I were to write this, I could write it as this is f prime g, g prime f. Also notice the exponent here is 1. And so according to this, the product rule, this becomes 3 to the power of 1 plus x or x plus 1. This one and 3, the same thing. This one, and this one, the same thing. So we write 3 to the power of x plus 1 for the first one. We put plus 3 to the power of x plus 1 for the second one times ln 3 times x. And now, as you can see clearly, this is a common factor times 1 plus this piece, which we call it x ln 3. We put the x in front. F of x is x to the power of 4, e to the power of 2x. We use the product rule and we put a raised dot here. And we call this f times g, and we use the product rule f prime for x cubed times g e to the power of 2x plus g prime e to the power of 2x. Exponential, immediately the answer is itself. 2x gives you 2. That's g prime f x to the power. Done with calculus. We take a common factor out between 4 and 2. 2 is in common. X cubed and x to the power of 4. X cubed is in common. These two are identical. So that is in common. So factoring, in other words, a lot of algebra is a big part of your work. So 2x cubed e to the power of 2x. This one, when you divide by this one, gives you simply 2. When you divide this one by this one, it just gives you x. So the parentheses would be 2 plus x. This is the product. F of x is 9x times x minus 1 to the power of 4. We put a raised dot in between to show that we are going to use the product rule, and let's call them f g. So we need f prime 9 times g x minus 1 to the power of 4 plus g prime. We are going to differentiate this using the extended power rule. 4 times x minus 1 cubed times the derivative of the inside, which is 1, and times f, which is 9x, and we are done with calculus again, everybody. So what do? We obviously have to take a common factor. So what is in common? 9. What else? X minus 1. Since this one has exponent 4, this one has exponent 3, we go with the smaller of the 2, which is 9 times x minus 1 cubed. So that's important to understand, everybody. When we divide this one by this one, just gives us x minus 1. When we divide this one, so x minus 1. When we divide this one by this one, gives us 4x. we're done. We all have to do is to simplify the brackets. X and 4x, they add up to 5x. So 9, x minus 1 cubed, 5x minus 1. And that's the final answer, everybody. Extended power rule. G of x to the power of 3, something to the power of 3. N, put the 3 in front. Same thing to the power of n minus 1 to the power of 2. And now the derivative of the inside follows the quotient rule. I'm going to call this f over g, and I'm going to use that one. So I would write this formula, I would write this formula and follow it. So this gives me f prime 4 times g, the denominator is 2x minus 9, minus g prime, the derivative is 2, times the numerator 4x, and then I write the denominator squared. Done with calculus. Let's do algebra. This gives us 8x minus 36 minus 8x, and these two cancel each other. Now we want to simplify and write. Remember, this was the only calculus step. This is algebra. We're going to do more algebra. So notice we can write a fraction bar. What's at top? Number 3 is at top. 4x squared is at top. Minus 36 is at top. So the product of those 3 pieces. What's in the denominator? 2x minus 9. Pay attention. Squared. Also 2x minus 9 squared. So the bottom becomes 2x minus 9 to the power of 2 plus 2 or 4. So that's the denominator. The numerator was explained. And this is 16. X squared. Multiply this one, this one, this one. You get this answer. Please don't forget the negative sign. On purpose, I put it in a different color. We keep that. We can put it in front of a fraction bar, or at top we get minus 1728 x squared over 2x minus 9 to the power of 4. F of x is cosine 5t over 5t. So we are going to differentiate this, and again we are going to use the quotient rule. So I'm going to call this f over g. So f prime cosine, the answer is minus sine. Cosine, the answer is minus sine. Minus sine of what? The same thing, 5t. And then by the chain rule times the derivative of 5t, which is 5, times g, which is 5t, minus g prime minus 5 times f cosine of 5t, g squared. Square this, 25t squared. Done with calculus. We are going to take out, as you can see, negative 5 is in common. So I take out negative 5. I factor the numerator, negative 5, 5t sine 5t plus cosine 5t. The negative remains, but the 5 can cancel out the 25 and change it to 5. And the final answer is minus. We keep this negative sign. We don't lose that. And whatever is in the parentheses up here, 5 t sine of 5t plus cosine of 5t over. Now this has changed to 5t squared, this negative. You keep it in front of the fraction bar. If you want to take it to the top, put this in a parenthesis, put it in front, or distribute it, minus 5t sine 5t minus cosine 5t. It's your choice, but understand that this negative sign doesn't go away. Again, whenever you're dealing with a rational function or a fractional expression, you ask yourself, can I simplify it? Now, simplification means if there is a factor of x plus 3. So that should help you with the factor. First and foremost, 2 is a prime number, so you have x and 2x. Secondly, for 9, the product is 1. In order to get to the product of 9, the factors are 1 and 9 or 3 and 3. You can do the trial and error, and you're hoping that x plus 3 is there. It happened to be there. If it's not, everybody, if it's not, we have to use the quotient rule. But that's why you want to check to see if there is an easier way. 2x plus 3, the answer is y prime equals 2. It's a very simple process. Make sure, use your algebraic techniques first to make life easier. And it does make it easier. Example 7. The growth in world population in millions is estimated by the formula P of t is equals 3100 e to the power of 0.0166t, where t is the number of years since 1960. Find the instantaneous rate of change for the year 2015, include units. First and foremost, if they want the population in 2015, you look at the difference, which is 55, you plug it in. They want the rate in one point in time, that means instantaneous. Even if they don't mention it, that means differentiate. So P prime of t, you keep the number in front. And then this is exponential, the answer is itself. And then times, this is kx times k times the coefficient of t. To simplify it, you multiply these two numbers, you put it in front. This would be P prime of t if we were interested in the derivative only. However, in the year 2015, the difference between the 2 years is 55. Plug in. When you plug in, you use a calculator. And with a bunch of decimals, you get to this answer now. What are the units? P prime of t is dp dt, change in population in million over change in time in what? Years. So the units would be million people per year. Now, million has 6 zeros. We have 4 decimals. 4 of them cancel that, and then we have 2 more zeros. We end up with the following. In 2015, the world population was increasing at a rate of 128,227,300 people per year. The length of a growing Tasmanian devil is estimated by the function L of W is 2.265 W to the power of 2.543, where W is in kilograms and L is in millimeters. Its weight can be estimated by W of t is equal to 0.125 plus 0.18 t, where t is its age in weeks. How fast is the length of a 30-week-old Tasmanian devil changing? First and foremost, we want the dt. According to Leibniz's notation, dy dt is dy du dt. U is the intermediate variable. We've done a question like this previously. We would find the length and the weight first, because that's what they were asking. They haven't asked here. You don't have to calculate them. Of course, at some point we will need them. But in order to go from L to T, the intermediate variable is W, so dL dW dW dt. That's first and foremost understanding why you would use dl, dw, dw, dt. So what is dl, dw? You go to this one and you say 2.265 doesn't change, times 2.543, the exponent becomes the coefficient, and w to the power of the same thing minus 1. So in other words, we are using the extended power rule, so this changes to 1.543. So this remains, this becomes the coefficient, this goes down by 1 to 1.543 times dw dt, just 0.8. You put the three numbers together, you multiply them, and you end up with 1.0367811 w to the power 1.543. You carry a lot of decimals, although it's an estimation. Most of the time, they will ask you how many decimals. Now, we want to know how fast the length is the length of a 30-week-old Tasmanian devil changing. So you have to change the t to 30. So, but this is not a function of t. You have two choices. You can make it a function of t by putting 0.125 plus 0.18 t instead of w and plug in 30, or just plug it in here and find the weight when it's 30 weeks old. That means 0.125 plus 0.18 times 30, and the calculator gives us 5.525. Now you can replace it with that. Put it into a calculator. The answer is 14.4912. The LDT, the change in length over the change in time, millimeters per week. So that's why the units are millimeters per week. Second method, find L as a function of t. That means replace the w with the expression 0.125 plus 0.18 t. Now differentiate that and you call it the LDT or L prime of t. To differentiate that, you have this number. You put this number in front. You put the same thing to the power of this number minus 1. And by the chain rule, the derivative of the inside, 0.18. Put the three numbers together by multiplying. And if you look at these two, you'll see that this number in front is the same as this one. And W, if we had replaced it, we would have got the same answer as we have here. So it's very straightforward, and I hope everybody is following that. Now, of course, you can plug in and finish the job. What I want to add is that they didn't ask for the length. If they did, what is L of 30? So you use W of 5.525. We had calculated that into this, and now they didn't ask for this. If they did, almost 175 millimeters. The graph of a function f is given in the figure. Use it to sketch the graph of the derivative f prime. So we want to discuss a few interesting and important aspects of that. Number one, relative extrema max and mean happens when f prime is 0. That means peaks and valleys. F prime is positive, f is increasing here and here. F prime is negative, f is decreasing. So we draw a short horizontal line segment. And if you look at those three, meaning if you go with the graph of f prime, when x is a, y is 0. When x is b, y is 0. When x is c, y is 0. That means those are the three x-intercepts. Okay, that's the meaning of that. Now, so they corresponds to a prime, b prime, c prime. Now, f prime is positive, negative, according to being increasing, decreasing. I want to discuss this point also. They found this by precisely drawing a line, calculating the slope by picking up 2 points. The purpose of that, this will correspond to 5,3 on the graph of this function. This is decreasing, so below the x-axis, decreasing below the x-axis, but it has to come back up to 0. Positive, okay, above the x-axis because it's increasing above the x-axis. And it's a much better graph, of course, but that was a rough sketch. And as you can see, this corresponds to 0, corresponds to 0, corresponds to 0, and this 0.5, comma 3/2 or 1.5. That's the idea. The graph of a function f is given. Use it to sketch the graph of the derivative f prime. Please understand you have 1, 2, 3, 4 line segments, and you have sharp corners. So, reminding everybody, a function fails to be differentiable if it has a sharp corner, discontinuity, or a vertical tangent line. And we do have sharp corners there. Okay, so we will discuss the sharp corners in a moment. So for now, if you think about just one line segment, this one, if you calculate the slope and whatever the slope is, let's make it up, the slope is -8, then y equals -8, the horizontal line would be the answer. So let's calculate the slopes by plotting pairs. Roughly, those are the given. And for the first one, rise over run. So y sub 2 minus y sub 1, 0, minus 1 over x sub 2 minus x sub 1 minus 1 minus minus 3 results in -1/2. So m is -1/2 for this one, +1/2 for this one, +1 for this one, -1 for this one. So starting with this one, we are going to draw a horizontal line y equals -1/2. And it's this portion and it stops here. So we're going to stop here. Why is this a hole? Because we have a sharp corner here, here, and here. And this corresponds to this point. If you look at the rest of them, m equals 1, y equals 1. M equals -1, y equals -1. M equals 1/2, y equals 1/2. Those are the horizontal lines. So for example, this piece only covers this much. So we cover from here to here. And the endpoints are sharp corners, therefore holes. This one is this one. And this one is this one. Very straightforward. I hope everybody's comfortable with that. Find an equation of a tangent line for the graph of this function. Remember, in order to find an equation of a tangent line, or any line for that matter, you need two things. You need a pair, and you need the slope. The pair, you plug in. The slope, you find f prime, and you plug in. So f prime clearly is 2x minus 3. Let's plug in 4 here. We get 4 cubed. 4 cubed is 16, minus 3 times 4 is 12, minus 1, and we get 4 comma 3. Let's plug in 4 here. 4 times 2, 8 minus 3 is 5. And now we are ready. Y minus y1 equals m times x minus x sub 1. That means y minus 3 is 5 times x minus 4. And y equals 5x minus 70. What I'm going to remind you is that this pair must satisfy the original equation because it belongs to that. It must satisfy the tangent line because it belongs to that. And of course, you check it, it works, and simply means this part is done right. It has got nothing to do with that. We want to differentiate this, and I remind everybody that to do so, we have to change the square root of x to x to the power of 1/2. The exponent here is 1. So these two use the product rule, and it becomes x to the power of 1 plus 1/2, meaning 3/2 plus 5x minus 2. And now it's a very simple differentiation. F prime of x is 3/2 x to the power of 1/2 plus 5 because 3 halves minus 1 is 1 half, and then take it back to the format you received it, 3 halves square root of x plus 5, and we are done. H of x square root of x e to the power of x, and we are going to change the square root of x to x to the power of 1 half. In order to be able to differentiate, we notice is the product of the two pieces. We put a raised dot, and we call it f times g, and we are going to use the product rule. Therefore, f prime 1 half x to the power of negative 1 half times g e to the power of x plus g prime is just itself e to the power of x times f, which is x to the power of 1 half or square root of x. Now we are practically done here, class, as far as the calculus is concerned. So notice this is x to the power of 1 half down here, positive 1 half down here, or square root of x. To combine this, because we need it for later on, we are going to use algebra, and to do that, please notice that if you think of this as a LCD, 2 square root of x. And so the first fraction is this, and you're done with the first fraction. I mean this one, right? The second one, you have to raise it by the denominator. So 2 square root of x over 2 square root of x. And when you multiply these two, you get e to the power of x times square root of x times 2. So 2 square root of x, and square root of x gives you x e to the power of x. You can leave it like that. You can factor e to the power of x, and you get 1 plus 2x. Or you can do it in this fashion and factor 1 over 2 square root of x e to the power of x. This is left with 1, this is left with 2x. So it's very straightforward. I hope everybody is okay with that. Okay, let me erase my mess. And so you are dealing with quotient rule f over g. So we are going to use the quotient rule. So I would write the formula and follow that. F prime is e to the power of x times g, which is 1 plus x, minus g prime is 1 times f, which is e to the power of x, over the bottom squared 1 plus x quantity squared. Done with calculus. We are going to finish the job by distributing. This is e to the power of x, e to the power of x times x minus e to the power of x. And obviously these two cancel each other. So you're done. The numerator, however, we put the x in front. So x e to the power of x over 1 plus x quantity squared. That's a better way of writing it, class. We're going to differentiate. And as I've mentioned it during the lecture, because 5 is a simple number, you can keep it as part of x. But if it gets involved, that means it's extremely large, or it's a fraction, or it's a decimal, then you put brackets and you keep it out. And I'll show you that one also. But just the way it is, we are going to go with this is f, this is g. So we have f prime, which is 5 times g, which is 3x minus 2 to the power 4, plus g prime. Use the extended power rule, 4 times 3x minus 2 cubed, we're taking off 1. And the derivative of the inside is 3 times f 5x. Done with calculus. We can replace this with 4 times 3 times 5, 60x times, so you can ignore that. This one basically is replaced. Okay, this one is replaced with this one. We're going to take a common factor between 5 and 60. 5 is in common, and this one with the exponent smaller of the two, 5 times 3x minus 2 cubed. Divide this one by this one, everything goes away except 3x minus 2. And divide this one by this one, everything goes away except 12x. So the first one gives you 3x minus 2. And the second one gives you 12x. Combine the two, 15x, and you're done. All right, I want to mention the second method. And the second method is this. Let me erase everything. If this number 5 is involved, what do? You do it like that. And then this 5 remains as a coefficient for everything outside the brackets, and it keeps on going, so it's not going to go away. So now you're dealing with f g. So f prime is just 1 times this one. So this one becomes 1 times this. And then this is the same thing times 5x. It would be times x. See, again, one more time. The derivative of x is 1 times the second piece. The derivative of the second piece is the same thing that we had here times the first piece. Now it's x instead of 5x. And I'm not going to finish it, but if you finish it, you get this point. There's no difference between the two, everybody. Okay? And again, the reason I'm showing you this method, it depends whether this gets involved or not. 1 over 7x squared minus x to the power of 4. You don't want to use the quotient rule on that if you don't see the easy way out by bringing it up. Okay, using negative exponential numbers, a to the power minus n is 1 over a to the power of n, 1 over a to the power minus n is a to the power of n. If you don't see it, the quotient rule, it's going to be very difficult. So now you use the extended power rule. First we have negative 4. Then we have the same thing to the power of negative 5, because minus 4 minus 1 is minus 5. Then the derivative of the inside, 14x minus 1. So this thing goes down with a positive exponent 5, and you're done. We want to differentiate this. We are going to use the quotient rule, f over g. So f prime is 1, just times the bottom, 2x minus 1 to the power 4. Minus g prime. Now g prime uses the extended power rule. That's why it's the chain rule in conjunction with the quotient rule. So 4 times 2x minus 1 cubed times 2. So you're done with g prime times f, which is x. Denominator g squared, just write this one. How do you square it? Power of 8. Done with calculus. Let's simplify. First and foremost, the numerator 2x minus 1 cubed, because this one is smaller than this, is in common. So this one gives you 2x minus 1. And this one is completely gone. Minus 4, 2x. Their product is minus 8x. So this one as exponent 3 completely goes away, and 8 changes to 5. And this one, so you write, so the denominator is 2x minus 1 to the power of 5. Numerator, minus 6x. minus 1, and we're done. Y equals 4 over square root of x squared plus 3. We want to differentiate that. You don't have to use the quotient rule. This one is to the power of positive 1/2, bring it up to the power of negative 1/2. So this has got to do with algebraic techniques, everybody. Now we are going to differentiate. So 4 remains. We are using the extended power rule, everybody. We are using the extended power rule. So n negative 1/2. G of x to the power of n minus 1. So the same thing to the power of subtract 1 becomes negative 3/2. So this is minus 1/2 minus 1, minus 1/2 minus 1. And finally, the derivative of the inside, which is 2x. Done with calculus. You can do this in one shot or a couple of steps. 4 negative 1/2 2x, their product is minus 4x, put it in front. 4 negative 1/2 and 2x. So this goes down and take a positive exponent 3/2. And now we put it in the same format. We put minus 4x over the square root of x squared plus 3 to the power of 3. Cosine. The derivative is negative sign. But every trig function must have an argument. I think I've mentioned that many times before. This is called the argument of cosine. So we have the same argument. By the chain rule, now I need its derivative, which is 12t cubed. Or you can use one of these two formulas. Okay, understand that's the concept. And so finish the job by putting the 12t cubed in front. So minus 12t cubed sine of 3t to the power of 4, and we are done. We want to differentiate x squared plus 4x over x to the power of 6. As always, anytime you have a rational expression, see if you can simplify it. This is easy. You can factor the x out. Or just make up two fractions. Either way, you get x plus 4 to the power of 6. And now 6. So y prime is 6. X plus 4 to the power of 5 times the derivative of the inside 1. We are using the extended power rule. We rewrite it. We are done. Y equals 2x plus 3 over x minus 8 to the power of 5. We are going to use the extended power rule in conjunction with the quotient rule. So first and foremost, we need 5. Then we need the same thing to the power of 4. F over G, we are going to use the quotient rule. F prime 2 times G x minus 8 minus G prime 1 times F 2x plus 3, and then G x minus 8 in a parenthesis squared. Done with calculus. 2x minus 16 minus 2x minus 3, 2x minus 2x cancel each other. These two add up to negative 19. And so we have a fraction bar. First of all, I'm going to separate this just in this time so you can see this is the power of 4, and so this is this one. And I write the second piece. 5 times negative 19, meaning negative 95 is in the numerator, including 2x plus 3 to the power of 4, these two. X minus 8 to the power of 4 plus 2 makes it x minus 8 to the power of 6 in the denominator, and we are done. Exponential functions. The answer is always itself, class. And then some more. So I would say, okay, y prime is itself. Then times 10. Part B, the answer is itself, e to the power of 10x times the derivative of 10x, secant squared x. So we are using this one or this one, if you will. And now 3 to the power of x, the answer is itself. The base is e, no, ln 3, and just rewrite. The next one, the answer is itself. Is the base e? No, ln 5. And then the derivative of the exponent by the chain rule, 60x. And we rewrite it as 60x. Ln 5 times 5 to the power of 30x squared. You remember this question was done last time. Observations show that the length from nose to tail of a Siberian tiger is given by this equation. L equals 0.25 W to the power of 2.6, where W is the weight of the tiger in kilograms. Furthermore, a young tiger's weight can be estimated in terms of its age t in days by function W equals 3 plus 0.21 t. And so how long is the tiger when it's 100 days old? Well, length is a function of the weight. Weight is a function of the time. If you replace the weight with this, L becomes the function of the t, and you have the answer. We will look at that format. But for now, let's plug in 100 into this one. Two decimals, two zeros cancel each other, we get 24. And now put the 24 here, use a calculator, you get 969.369 millimeters, and you're done. This was elementary algebra, and as I mentioned before, remember 1 meter is 100 centimeters, or 1,000 millimeters. And so we want the LDT, in this case where it's asked for at what rate is the length increasing when it's 100 days old, we want the LDT. And I'm going to write it in this fashion, and I'm going to remind you that according to Leibniz's notation, dy dt is dy du dt. So from y to t, the intermediate variable is u. So from L to t, the intermediate variable is w. So that's what we put in here. So dl dw is simply 0.25 times 2.6 w to the power of 1.6. And dw dt is just 0.21. The product of the three numbers is 0.1365 w to the power of 1.6. And because we want to see what happens after 100 days old, we have two choices: replace the w with this and t with 100, or we already know w of 100 is 24. Replace it with 24. That gives you the answer. The units, the LDT, change in length over change in time, millimeters per day. The second method, and we have done this, I will replace the w with 3 plus 0.21 t, their composite function. And now this is L of t. After 100 days, just replace the t with 100. and it will give you the same answer that we found here in the first place. Now, the LDT or L prime of t, we're going to differentiate this, which is 0.25 times 2.6 times the same thing to the power of 1.6 times the derivative of the inside, which is 0.21. So differentiate this using the extended power rule. And multiply this number, and this number, put it in front. And as you notice, these two are identical. If we had replaced the W here, we would have got the same answer. And so, of course, after 100 is just so you can put the t equals 100 here, and the number it gives you is the same as this one. Units, of course, are the same. The amount of glass recycled in a community is G of P equals square root of 0.5 P squared plus 7 tons. Where P is the population in thousands, it is estimated that 2 years from now, the population of the community will be P of T equals 4.4 plus 0.1 T squared thousands. How many tons of glass are expected to be recycled 4 years from now? So again, glass is a function of P, the population is a function of T, so you can replace the P with this one and come up with the answer in one shot. However, in this example, finding the composite function actually makes things more complicated. Just the way it is, replace the T with 4. 4 squared is 16 times 0.1 is 1.6 with 4.4 is 6. 6 what? 1,000 people. And now we are going to put the 6 in here. And when we do that, this is 36. Half of it is 18, with 7 is 25, and its root is 5 tons of glass. Elementary algebra. Find the rate at which the amount of glass recycled is changing with respect to time 4 years from now. So you want dg dt. And again, with the Leibniz's notation, what is the intermediate variable? Going from g to make it a function of t, the intermediate variable is p, so dg dp dp dt. Now this is a simple differentiation. First, we take the derivative of the g with respect to p. To do so, we are going to change this to the power of 1/2. And its derivative is 1/2 times the same thing to the power of negative 1/2 times the derivative of the inside 0.5 times the 2p makes it 1p. So one more time. First, let me erase some of this stuff. So 1/2 sits in front, the same thing to the power of 1/2 minus 1 makes it negative 1/2. The derivative of the inside, 0.5 times 2p is p. dp dt is just 0.1 times 2t. That means 0.2t. Right here, you can replace the p with 6t with 4, come up with the answer. But let's simplify it first. Notice you have a fraction bar 1/2. So in the numerator, you have 1, you have p, you have 0.2t. In the denominator, you have 2, and take this one to the bottom and make it to the power of positive 1/2, which makes it square root. So one more time. In the numerator, we have 1, we don't have to write it, p and 0.2t. In the denominator, we have 2, we have to write it. And this one, take it down, make it positive 1/2, and in this format. Now, all you have to do, plug in 6 and 4. So what happens when you plug in 6 and 4? So this is 6, this is 4. And this part, I already have shown you when we plug in, we get 5. So it's 5. So we have 4.8 over 10, or 0.48 tons of glass per year, which means 4 years from now, the amount of glass recycled is increasing at a rate of 0.48 tons of glass per year. Now, if we want to find g of a t, all we have to do is replace the p with this. So g of t becomes square root of 0.5. P is 4.4 plus 0.1 t squared plus 7. Now, if you want to differentiate this, it's, I believe, more difficult than this Leibniz's notation. So you can find the composite function, yes. Can you differentiate it? Yes. But I believe it's a tad longer. So I don't recommend that. That's why you need to know both methods.